This is the intro video for Algebra 1 for the concept of simplifying radicals. All right, so when working with square roots, radicands that are not perfect squares, could either be approximated with the use of a calculator, or we could reduce them to a simpler form. We will use a factor tree to help us reduce these square roots. All right, so we're going to do two examples here in this video. So first thing we're going to recognize here, of course, is that the radicand here is 12 and it is not a perfect square. So we're going to try to simplify it. And the way we're going to simplify it is to use that factor tree. And so I'm going to think to myself, what two numbers multiply to be 12? Several different answers here. I'm going to say 2 times 6. I want to recognize, of course, that 2 is a prime number. And so we're not going to be able to go any further down that branch of the factor tree. But the 6, of course, is not a prime number. We ask ourselves then, what times what is 6? And the answer, of course, would be 2 times 3. And then we'd recognize that the 2 and the 3 are both prime numbers. So we can't go any further with those. All right, so once we have established that, we are going to go in and rewrite our radical. And rewrite our radicand as, instead of the square root of 12, it'll be the square root of 2 times 2 times 3. Okay, so then how do we use this? Because we're looking at a square root, the index, of course, is 2, so we're going to be looking for pairs of like factors here. And so we can obviously see that the 2 times 2, those are 2 and 2 are the same number. And so because of that, because we have a pair of 2's, we can simplify that. And the way that we simplify that is to recognize that because there are two 2's, it's really a 4, and the square root of 4 is 2. And so this pair of 2's gets to come out of the radical as just a single 2. So it would be 2 times the square root of 3 for our final simplification. Again, just want to emphasize, if you do have a pair of factors, like in this case the 2's, those 2's can come out of the radical, but they come out as a single 2, because bringing them out of the radical is really just square rooting them, and the square root of 4 is 2. So this right here would be our final simplified version of the square root of 12. And our other example for this video is right here. We're going to simplify the square root of 200x cubed. So once again, we recognize that 200x cubed is not a perfect square, and so we're going to use a factor tree. And I'm going to use a factor tree just for the 200, and we'll talk about the x cubed here in a second. So I'll just come off to the side and say, all right, 200, what times what is 200? Maybe the most obvious would be 2 times 100. Once you've got that, of course, you'd recognize the 2 is a prime. 100 is not, so we're going to ask ourselves what times what is 100. I don't know, to me 2 times 50 makes sense. And of course the 2 is prime. 50 is not. We ask ourselves what times what is 50. Again, 2 times 25 makes sense to me, with the 2 being prime, the 25 is not. And finally we get to what times what is 25. The only answer here would be 5 times 5, and those two 5's, of course, are prime. Okay, so remember, what we're going to do is use this now to help us simplify this radical. So the square root of 200x cubed could be rewritten as the square root of 2 times 2 times 2. There's 3 of the 2's, and then there's 2 5's. So times 5 times 5. And then the x cubed. Well, x cubed, of course, is just x times itself 3 times. So it would be times x times x times x. So the trick to simplifying these radicals now is to look for pairs of like factors. So I see a pair of 2's, and I also see that there's an extra 2 that doesn't pair with anything, so we're just going to leave that one alone. I also see that there's 2 5's. And finally, I see that there is a pair of x's, of course, acknowledging that there is an extra x in there as well. So just like before, if you've got a pair of like factors, you can bring out that like factor. It'll come out as just a single of that pair. So I've got 2 2's in there, so that comes out as a single 2. I've got 2 5's, so that'll come out as a single 5, so it'll be 2 times 5. I've got a pair of x's, and so those would come out as a single x, so times x. And then, of course, there is some stuff left over inside the radical. So there's a 2 left over inside, and there's an x left over inside. Neither of those had another factor to pair with. Okay, so you end up with 10x root 2x. This would be your final simplified version of the square root of 200x cubed. All right, we'll practice these when you get to class. I'll see you then.